Now students, in this video, we will be looking at other techniques that are used to solve or find limits. Your heading today is Solving Limits by Simplifying. Solving Limits by Simplifying. We are finishing up lesson 3.3, and be sure and include today's date, okay? Solving Limits by Simplifying. So yesterday we looked at solving limits by graphing. We looked at solving limits analytically. And now we're going to look at solving limits by simplifying, okay? Lesson 3.3, and be sure and include today's date. In the previous video, we noticed there were limits that, when you substituted in a value for x, they seemed to be undefined or no solution. The limit seemed to be undefined or no solution. Yet, when you took that same limit and you graphed it, you could see this wasn't the case at all. There was actually a solution to the limit. Now, you might not remember, but we looked at a couple of those yesterday, or in the previous video. Let me refresh your memory by giving you an example of one of these limits that I'm talking about, okay? Copy this in your notes if you would, please. If I ask you to find the limit of this expression here as x is approaching -3, there is a negative sign there, as x is approaching -3. Now, go ahead and copy this down. If you were to substitute -3 in for x, you would get the following. You would get out 0 over 0, alright? 0 for the numerator, 0 for the denominator. So, if you tried to solve this analytically, and you put -3 in everywhere there was an x, you would get out 0 over 0. So you would say, okay, there's no solution to this limit. That's not correct, though. If you were to graph this limit, you would see that the limit actually exists, and the limit is -5. So in other words, you would see the graph is approaching -5 on the y-axis. Okay? I'm not sure what that graph would look like. I'm not going to worry about that right now, but my point is these are the types of problems I'm talking about that we're going to look at today. It's when you try to solve them analytically by substituting this number in, and it doesn't work. But there's still actually a limit. So what do you do? Well, yesterday we graphed those. Alright? So what we're going to do today is we're going to take these problems here like the one above, and we're going to learn how to solve them without graphing them, okay? We're still going to use substitution. Alright? We're not going to graph them. Now, this should make you happy, guys, because graphing is quite often a pain, okay? So this should be something you should be happy about. We're going to learn how to solve these limits in another way other than graphing, alright? So let's go ahead and jump into this. It's going to be a pretty short video today, 2 problems, and we're finished, alright? Now, let's solve the last problem we just looked at by using substitution. And of course you're going to say, Mr. Earhart, that's impossible. We tried it already. If you put -3 in, we get 0 over 0. And you're right, that's true. But let me show you how to do this, okay? Now, what we can do is this. What we can sometimes do, this doesn't always work, but of course, in your homework tonight or today, all the problems they give you can be simplified. But sometimes you can take this limit right here off to the side and kind of work on it a little bit like this. If you factor the numerator, you would get x plus 3, x minus 2, because a +3 times a -2 is a -6. However, if you add +3 and -2, you get +1. Now in the denominator we have what? X plus 3, look at that. Isn't that a coincidence, okay? So we factor the top, the bottom can't be factored. Look what cancels. So this whole expression here really equals this. So I'm going to rewrite my limit now like this. I'm going to find the limit of x minus 2 as x approaches -3. And you say, Mr. Earhart, you told us the answer earlier is -5. Remember, guys, I told you that right over here. I told you the answer is -5. So if you're wondering, if I were to graph this, would I get the same answer as negative 5? Yes. And also, now that I've simplified this fraction, I'm going to go ahead and take negative 3 and substitute in for x. So I have negative 3, negative 2. So the limit of x minus 2 as x approaches negative 3 equals what? Negative 5. So let's go over this again. When you are solving limits, one of the easiest ways to solve them is to pick up the number and put it in for x. Now we did that, and that's always the first thing you should try to do. But we got 0 over 0. That didn't help. So the next thing we try to do is we try to simplify this expression. And in this case, it definitely simplified this entire fraction, reduced down to x minus 2. So instead of using this expression here, we use this expression right here. And then we go ahead and find the limit because x minus 2 is the same thing as this expression here. So I then go ahead and substitute negative 3 in. And negative 3 and negative 2 gives me negative 5, okay? So a pretty simple problem. The ones in your homework are not that difficult. You just have to be taught how to do these, okay? Alright, moving on to our last problem. Let's look at another problem where substitution does not seem to work, but it actually does work, okay? Here's the problem now. Go ahead and copy this in your notes, please. And let's take a look at this problem. Go ahead and copy this in your notes. Now the first thing you should normally like to do is put 0 in for x. So if we did that, we would have the square root of 0 plus 1, and then minus 1 all over 0. 0 plus 1 is 1. The square root of 1 is 1. 1 minus 1 is 0 over 0. So once again, students, we're getting out something that's not going to help us find the limit of this expression. So what we have to do is see if we can simplify this. Now, you've never been taught how to do this, so let me teach you how to do this. You've been told your whole life to rationalize the denominator. Well, in a situation like this, we're going to rationalize the numerator, okay? The numerator. So here's what we do. Now watch this carefully. It's really cool how this works. We're going to multiply the top and the bottom. Oh my goodness, what is the word I'm looking for? It's not reciprocal. Okay, I'm back. I had to pause the video and think about conjugate. You're going to write the conjugate of this. So you change the sign of the second term. So the square root of x plus 1. You have a negative 1 here, so I'm going to put a positive 1. Times, and then the same thing down here. Square root of x plus 1. Plus 1. Now, do you see what I did? I'm rationalizing the numerator. So I took the conjugate of the numerator. We look at this as one whole term because the square root pulls these two terms together. So that's one term. This is my second term. Remember, when you're writing the conjugate, you change the sign of the second term, not the first term. Okay? So having said all of that, here's the conjugate. Now, I'm going to take this and I'm going to simplify it. And it's really pretty simple because I have taught you guys. Let's look at a really easy example up here. If I had 3 plus the square root of 5, the conjugate of that is 3 minus square root of 5. I taught you guys there's a shortcut. Anytime you're multiplying conjugates together, you multiply the first term and you multiply the last term. And that's all you have to do. It's a shortcut that only works when you're multiplying conjugates, okay? So I'm going to multiply. This is a conjugate here. And a conjugate, we're multiplying conjugates together. So take the first term times the first term. Well, the square root of x plus 1 times the square root of x plus 1 is just x plus 1. Negative 1 times positive 1 is just negative 1. Easy enough. Now, take your x and multiply it through the parentheses. So x times this radical would be x. I'm going to write it like this, and you'll see why in a second. I'm going to go ahead and put x parentheses square root of x plus 1 plus 1. That's how I'm going to write it. Now, you'll see why in a second why I did that. Now, you're more than welcome to multiply that x through. If you did, you would have x square root x plus 1, and then x times positive 1 would be 1x. Alright? Now, having said that, you could do it that way, but it's easier to leave the x on the outside, and I'll show you why in just a second. Now, watch this carefully. I'm going to simplify my numerator. So I have x over this whole expression right here. And now I think you guys are seeing why I left my x on the outside. This x here cancels with this x here, so I'm left with 1 over the square root of x plus 1, and then plus 1. So everywhere there is an x, remember this whole expression here has now been simplified to this expression here, okay? So I'm no longer taking the limit of this function, I'm now taking the limit of this function. So everywhere there's an x, I'm going to put a 0. So I would have 1 over 0 plus 1. 0 plus 1 is just 1. The square root of 1 is just 1. So I have 1 over 1 plus 1. 1 half. There you go. So the limit of this whole expression as x is approaching 0 equals 1 half. So let's quickly review. You always want to try to use substitution first to solve it analytically. If that doesn't work though, you have to take this expression and simplify it. Now in the last problem, that meant factoring and reducing. Here it meant rationalizing the numerator. But either way, you then change the original problem to look a little different like we did here, and then make your substitution and get out the limit, okay? Pretty short, easy video. Hope this has made sense today, guys. If you have any questions, don't hesitate to call or email.